Folks, in these next 3 videos, I'm going to solve this given system of equations here using one of 3 different methods. In this particular case, we're going to use Gauss-Jordan elimination. We'll also use matrix inversion and Cramer's rule, just with the caveat that there is no way that just 3 examples could show you everything you need to know about these methods, especially Gauss-Jordan elimination, as you arrive at situations where you have infinitely many solutions or no solution. But in this case, I'm going to do it for systems of equations that have unique solution, and we'll look at how these work in this example. If you would like to see other examples, go back to the previous weeks in which these methods were covered. So the first method is to solve this system of equations through Gauss-Jordan elimination. So let's go ahead and set that up. So here's our augmented matrix, 3, 2, 1, 5, with the augmentation bar 6, 17. Remember that our goal is to, in this first position right here, get a pivot if that's possible. And since this column is not of all zeros, it will be possible to get a pivot in this first position here. So let's go ahead and do that. The best way to do it in this case is to go ahead and stick to the algorithm. We're going to say that row 1 is 1/3 the old row 1. So go ahead and divide this row by 3, gives us 1, 1/3, and 2. And we didn't do anything to the second row, so we'll just leave it as is. Now, because we were able to get a 1 in this position here, we now, in the process of Gauss-Jordan elimination, want to get zeros above and below it. So that means I want to get a 0 in this position here. To do that, I'm going to go ahead and multiply my current pivot row, the first row, by the opposite coefficient of this entry. So I'm going to multiply my pivot row by -2, and then combine that new expression with the original row 2 to give me a new row 2. So let's just summarize that. We're going to say that the new row 2 is -2 times the old row 1 plus the old row 2. So that gives me, let's go ahead and just recopy the pivot row since we're not working with it. And then to find this new row, we're going to take the first entry, 1, multiply it by -2, and combine it. That gives me the 0 that I was after there. This is going to give me, when I multiply 1/3 by -2, -2/3 plus 5. Well, that's -2/3 plus 15/3, or 13/3 for that entry. Then we'll go ahead and multiply the number 2 by -2. That gives me -4. Added to 17 there gives me 13. So again, that was 2 times -2 is -4. Added to 17 gave me 13 there. So now that I've worked with this pivot position here and I've gotten zeros above and below it, my next potential pivot position is 1 down and 1 to the right of it. And as long as all subsequent rows, at least one of them has a non-zero entry in this column, we'll be able to make this column a pivot row. Well, yeah, there's not too many rows actually to be considering here, but it is possible to get a 1 in this pivot position. So what are we going to do? Well, let's go ahead and to get a 1 in that pivot position, we're going to say our new row 2 is equal to 3/13 the old row 2. And so operating off that row, let's see, this will give me a 0 here. This is going to give me the 1 that I was after there. And when I multiply 3/13 to 13, that gives me 3. Recopying the original row 1, we just have this expression here. Okay. Now I want to get a 0. Now that I was able to get a 1 in this pivot position by Gauss-Jordan elimination, I want to get zeros above and below it. So I want a 0 in this position here. And so I'm going to multiply my pivot row to get for my new row 1, I'm going to multiply my pivot row by -1/3 and add it to the row I'm working on, add it to row 1. So when I do that, let's just recopy the pivot row. This is what we have. Then I'm going to take and multiply this pivot row by -1/3 and add up. Well, that doesn't change the first entry. That gives me the 0 in the second entry like I wanted. And then 3 times -1/3 gives me a -1. -1 added to 2 gives me a 1 there. So this is solving this system of equations using the Gauss-Jordan elimination technique. You've seen this before, but I just wanted to give you a quick recap of it. Let me know if you have any questions.